Hello friends, welcome to the next video of Java online course. This is also one of the prime concepts used in almost all advanced Java technologies, we call as exception handling mechanism. Exceptions, what do you mean by exceptions? So you might have came across this point for multiple number of times. While writing the program, some kind of exceptions may have occurred, or if you are knowing C++ already, so you might be knowing the concept of the exceptions. So exception is a condition that is caused by runtime error in the program. Runtime error means program is correctly written, that is syntactically the program is correct, but because of some errors or because of some programming kind of things happened in the program, where program is not getting continued onwards. So the program will be interrupted or program will be terminated immediately. So because of that, the program is not getting continued, and this particular condition we called as exception. In computer programming language that do not support exception handling, errors must be checked and handled manually through the use of error codes and so on. Okay, it was previously possible with the help of some manual mechanism we were checking the errors in the program, so exceptions handling mechanism was not used, but this approach is cumbersome as well as troublesome. Java's exception handling avoids these problems, and in the process it brings on runtime error management into the object oriented world. C++ programming language supports exception handling, but Java has enhanced some of its features. Okay, some try catch mechanism was used, but Java has enhanced this particular concept to the next level to handle the exceptions. Now let's see what exactly the exceptions meaning is. Check out the program I have written on this particular slide. Class is uncaught, and inside it I have declared two variables. 23 is first integer and y the second integer. So I am printing system.out.println x divided by y. What will happen if I write like this? What do you think? What can be the output of it? 23 divided by 0 is it infinity? What do you think? Is it infinity? So maybe some confusing question. I'll find the solution. I'll explain the solution to this particular problem also in the exception handling mechanism. So let's see what exactly we can do. Okay, so this is your program. Uncaught exceptions. 23 divided by 0. So let's run this. Yes, check it. Exception in thread main java.lang.arithmetic exception by divide by 0 at uncaught x dot main and dot java file at 8. So what is the meaning of it? Now see, this is what we call as runtime error. Main is the thread. Okay, in thread concept we'll see in the upcoming videos what do you mean by threads. Thread is the single execution of the program, that's given main name here, that's the main method contains java.lang.arithmetic exception. This is the class, okay, which is present inside the lang package. Arithmetic exception has occurred. It means that program is terminated because of some arithmetic exception occurred, arithmetic operation which is not supported by the Java programming language. Because of that, this program is terminated. Okay, why? What kind of arithmetic exception is there? This is divide by 0. Okay, so program is terminated because of divide by 0. So this is called as the exceptions message. So this message will show you the reason why program is terminated. Okay, the reason is divide by 0, and it's coming under the category called as arithmetic exception. Okay, and now where this exception is occurred? So at uncaught.ex main, uncaught ex, this is the name of the class. Okay, in this class and in this method it is occurred. Where? In this particular file at line number 8. Okay, in this particular file line number 8, this is the name of the class, name of the method, name of the file, check it out, and line number. So here the exception has occurred. Which exception? Divide by 0 arithmetic exception. It means that 23 divided by 0 is generating an exception, and this is what we call as uncaught exception. Uncaught exception has occurred so that program is immediately terminated. Is that actually? See, so let's have one more variable here, z, and if I write z is equal to x divided by y. Okay, and here I will print the result. Result is z. Correct. Now let's check this. line number 8 I got the exception on this line, so that the last line is not executed. It means that program is immediately terminated on that number line. That's what we generally call as exception, or in what I told, it is runtime error. When program is running, that time it has got terminated because of some weird condition happened in the program. What that weird condition is? It is divided by 0. This is what we call as uncaught exception. Program is immediately terminated, but see what happens if we keep this number as 2. So let's run this. We got this number, integer divided by integer is integer, 23 divided by 2 is 11, and program is not terminated now. It means that program is correct, syntactically it is correct, but some operations which are not allowed by the programming language are happened. Due to that, program is getting terminated and it's not getting continued onwards. So if it is not getting continued onwards, program will be stopped directly because of the concept called as exception, runtime error. Now our task is to handle this exception. Means we can overcome this exception also, we can instruct the user to enter the proper values also, and we can stop the accidental termination of the program by exception handling. Okay, before doing this operation, I'll just show you a small concept here and then we'll go for the next. Okay, so if I write float value here, 23.0f, fine, and here also I'll have a float value, float y is equal to 0.0f, fine. Now 23 divided by 0, here also I am doing the same operation, but the result is in floating point format. What do you think? Will I get the exception? Let's try that and check the output. See, output is infinity. Yes, because infinity and not a number, nan, these two concepts belong to the floating point arithmetic. So when objects or variables are type float or double, in that case will generate the infinity when division by 0 is happened, or divided by 0 is there, then it will have the nan, that is not a number. Okay, so remember that it will not be the case for the floating point, but for integer values it's having the concept of exceptions here. Okay, so remember that. I will make it again clear. Okay, so uncaught exceptions. One more thing, uncaught exception in the functions or the methods. Okay, so how to do this one? So let's try to, okay, one thing that we need to remember, that when the exception has occurred, we must have ability to read the exceptions. Okay, what is ability to read the exception? In what line exception has occurred, what's the reason behind it, so that you can easily rectify that exception and we can make your program error free in that case. That's why this is possible. This is required to handle the exception, read the exception properly in the program. So let's go for some more changes in it. So uncaught now. So what's done over here? So in my class I am creating a method, static void call me. Okay, so in this call me method I am declaring x23 and y is equal to 0, and then I am printing this x and y on the screen, or let's have this concept again, z, and z is equal to x divided by y. Okay, and I'll print the z like result is plus z. Okay, let's run this. Okay, so before running, let's talk about it, what exactly is done over here. Here I have written the method, and inside the method the exception is occurred. Exception is not currently getting occurred in main. Okay, it's there in the call me. Here we'll have the exceptions. So this line will not be executed, program will be terminated, and here I'll write one more statement here. Okay, that is program completed. Okay, fine. What do you think? Result will not be printed, as well as program completed, this also will not be printed. Okay, so both of these statements will not be printed on the screen. So exception are there, but what exception is showing, that I want to show you, and I want to show that how to read this particular kind of exceptions or the error message. Check it out. Now see, the error message has changed a bit. How it is changed? Check it out. So exception is thread main java.lang arithmetic exception divided by 0. This line is correct, but at exceptions uncaught dot call me, exceptions occurred in the call me method. Okay, at line number 9, see this line number 9, here exception has occurred, and at exceptions again uncaught dot main, where line number 14 means this function is called here in line number 14. So when exception is occurred, the object of that type will be generated and it is thrown out of the program. That's why program is getting terminated. So once it is thrown from here, it will go to the line where it is actually called. This method is actually called. The method is called over here. That's why the program is terminated on this line finally. Every time the exception program will terminate in the main. Okay, it will show in the main on which line the particular function or method is called. Fine, if it is exception is there in the method, in that case only it will happen. So line number 14 and line number 9 both are shown by the particular output. See this, 9 and 14. Fine. So it will be easy for us to identify the actual source, okay, actual source of the exception plus where this function or method is called in the main. That's the last line will show. Remember, in between these two lines, multiple lines can also be present. When method is calling another method, that's calling another method, that's calling another method, in that case name of all the method will appear in this particular sequence. This is what we call as the stack trace. Stack trace. The stack trace will show you the sequence in which the exceptions are generated and they are printed on the screen. So try to remember how to read the exceptions. Line numbers are shown, method names are also shown. The last line will show the main method, and above that we can see the method where actual exception has occurred. Fine. So remember that. This is how we are going to read the exception. Try to identify how to read the exceptions, and then only we can find a solution on these particular exceptions, and we can handle these exceptions so effectively than others. Let's introduce a total 5 keywords are there associated with the exception handling itself. That 5 keywords are try, catch, throw, throws, and finally. These 5 keywords are used to handle the exception. We are going to see the use of all these 5 keywords in these 2 videos, this video and the next video also. So try, catch blocks. So let's see how try and catch blocks are used. Try. So we are going to create the first block, try. In this try block, we have to write the statement that may cause an exception. Okay, this is what we call as exception object creator. Yes, when exception is occurred in the try block, then this exception will be thrown out of the program, and there is a connected block called as catch. This catch block can catch the exception and perform the operation upon catching these particular exceptions onwards. Statements that handle the exceptions if it occurred in the try block. This is called as exception handler. So exception generator and exception handler. So try is the exception generator. Not always. It is possibility that exception may occur in the try block. When it is occurred, it will be caught or handled with the help of the catch block. Okay, so that we need to remember. Catch block will handle the exception and will take the action, perfect respective actions on that, and then program will not be terminated onwards. That you need to remember. Program will not be terminated onwards. Now let's write try block to it. So let's start with the first simple try catch can add to the arithmetic exceptions. Yes, so let's see this. Okay, so let's add the try and catch blocks to your program and try to identify how to handle the exceptions, simple exceptions in your program. So here I am making x equal to 56, y is equal to 0, and then this is my try block is try and catch. So in try block we need to write the statement where there is a possibility of occurrence of the exceptions. So line number 10 is showing this int z is equal to x divided by y. So there is a possibility that exception may occur there, or maybe exception will not occur. So I have given the constant value, that's why the exception will occur always. But if values are not constant, I am taking from the user, then depending upon the value there is a possibility of occurrence of exceptions there. Okay, and then I am printing the z value on the screen. Now connected to try, I am having one more block called as catch. Inside the catch we need to provide the name of the class, name of the exception class which you want to catch. Because what possibility is there? Possibility is for arithmetic exception, and object of arithmetic exception is generated in the try block which we are going to catch into the catch block. So it will be generated and we are going to catch here it in E. So E is the object of exception which is caught from the try block, and once it is caught then we are printing division by 0. So division by 0 is the message printed, and after that program will be continued. End of the program. This will also happen. Means program will not be immediately terminated. It will just show you this division by 0 and program will be ended. Check it out. See, division by 0 and end of the program. Okay, so this is why exception has occurred, and then it has caught the exception here, division by 0, and program is continued. It is not terminated immediately, it is continued onwards. Now if I make this number as 5, check this, and now let's run this. Value equal to 11, end of the program. So what happened actually? Catch is not executed. Why? Because exception is not occurred over here. That's why catch is not executed. Okay, catch is conditional. It is executed only when the exceptions are present in the program of that type only. Okay, if it is present for arithmetic exception, then only we are going to have the output on the screen, division by 0. If it is not, then the output will not be generated, and the respective output will not be shown again on the screen. Remember. Okay, so arithmetic exception is caught, division by 0, and end of the program. It means that we are not accidentally terminating the program. We are properly catching the exception here. We are taking some actions. So this is action I am printing. I am giving a message to the user that your values are not correct. So let's see, both conditions also we can make use of them over here. Let's import the java.util.scanner here, and then let's create the object here. So scanner in is equal to new scanner and system.in. Okay, and then here I'll ask the user to enter the enter first. Okay, so it will enter the first number, where I'm going to read x is equal to in dot next int. Fine. Okay, first variable, and I'll read the second variable also. Let's do this. Second variable here. One. Okay. Now this is happening at runtime. So it may change the values. Now see, enter first number 45, second number is 6. See, I got the value 45 divided by 6 is 7, and again I'll run this code. Now this time I'll have 66 divided by 0. See, division by 0. So in this case also program is not terminated. First time it was correctly done, second time also correctly done, means basically denominator is 0, then also program is not terminated, because the exception is occurred and I have caught this exception over here. That's why program is not terminated. We can immediately take an action based on the data given there. This is how you can handle the exception, and will continue your program without terminating it. Okay, so this is how simple operations can be done. Now exception in methods, that's also we have seen how exactly exceptions in the methods are handled. So same case, let's see exception in the method. Okay, exception methods. Okay, let's try. Here we're going to use the exception in method. Sorry, just a minute. Exception in methods, I need to use it from here. Okay, exception in methods. So let's try this code. Okay, so in this program my all the codes are saved. So let's go for exception in methods. Yes. Okay, so different methods which I can use to print the message about the exceptions. Now exception class contains some methods which will print you the data regarding the exceptions occurred here. So what I have done here, first variable int x equal to 56, second variable y is equal to 0, then same operations, but when I catches the respective exceptions, I am going to make use of different methods by which we can find the results or different messages that I can to show upon the reception of the respective exception. The first message or first method is get message. You can check it out. Get message method used to print only the message that respective method is containing. Let's see, for example, I'll keep remaining things in the comment here. and let's try what's the meaning of it. So check it out. Okay, first of all, now get message. So when exception is occurred, this E object contains a method called as get message. With the help of that, we can easily print the message which is generated from the respective exceptions. Let's check it out. See, message is divided by 0. If I want to print only the message given by the exception, I can make use of the get message method over there. So get message method will print only the message given by the exception. Okay, that's what the meaning of this particular statement is. Now along with that, we are having few more methods. So next method is very important, that is what we call as the print stack trace. So I'll just put remaining again in the comment, and let's see the output of the print stack trace. Print stack trace. Stack trace will show you the actual result which is shown in the red color on the screen. Okay, stack trace where the exception has occurred inside the method, inside the main, at the line number. All this information is called as the stack trace. If I want to show that, so it's not returning anything, I want to use in this way, e dot print stack trace. So stack trace will be printed by this. So let's try that. See, this is the stack trace. Print stack trace is printing java.lang arithmetic exception divided by 0 and end of the program. So it's showing at what error it's occurred. So one important thing is to remember that it is showing that message, it is showing the stack trace, but program is not terminated immediately. See, end of the program, the last statement is also executed there. So stack trace will print the information, complete information about the error, including the line number, method name, error, and message also. So stack trace can be used by this method. Okay, one more, that's called as toString. If I am printing the object into the string format, so what exactly happened, that I will show you. See, toString, e dot toString. So shift 6, I'll run this code again. Now see, toString, only the message, error, class name, and then the message, both will be printed with the help of the toString method, java.lang.arithmetic exception divided by 0. Okay, why it's happened? Because of this particular thing, that is toString method will print the object into the string format. This is how it's possible to print exceptions message and its name. Then along with that, one more is that if you print directly as it is, okay, if you print the object directly as it is printed in the form of a string. Okay, so check it out, it will be printed now in the form of a string. So let's run this code. See, referring object, this is the message. If you want to print directly e object on the screen, that's also possible. Referring object, directly object will be printed. So that object contains the name of the class plus the message why the exception has occurred and why the program is accidentally immediately terminated. That also we can see by this particular mechanism here. So these are the ways by which we can handle the exception. We can see why the program is accidentally terminated. We can identify what are the reasons of termination of the program is, and based on that we'll generate the result. Okay, now few more properties that it also contains. It's called as multiple catch. Now before actually starting with the multiple catch, I'll show you a simple example here by which you can identify why the program is getting accidentally terminated or not accidentally terminated. So I'll go for arithmetic exception here. So what I'll do, I'll make a small change here. So let's see, value is printed, and here I declared int x. Okay, x of some arrays I'll declare here. Fine, okay, correct. Now x is equal to, sorry, x is already declared, so we'll have a here set, sorry, a, and then a of 89, sorry, a of 8 is equal to 45. Fine, correct. What do you think? Is there any syntactical error here? No, not actually. Syntactical errors are not present in it. But what will happen now? This line which I am currently highlighted with is having one error. Okay, error, maybe this is a one-time error present there. What error is that? And whether that error or exception is caught by the catch block or not, that we'll see. So let's run this code. So I'll enter the first number 45, second number is 5. Yes, value is 9. Value is 9. It's correct. But check it. We are having the exception called as array index out of bounds. X java.lang.array index out of bound exception 8. 8 is the message. So 8 is the number which is mentioned over here. Because of that 8, array index outer bound exception has occurred at arithmetic exception main arithmetic exception dot java at line number 17. Here this exception occurred, which are array index outer bounds exception. Because of the 8 number it has occurred, and we are not catching this exception over here. That's why program has got terminated. And to override the termination of this program, in this case, what to do, that we are going to see in the next video. The second part of the exception handling is very important concept. Try to remember it, try to practice this. We'll continue with the next session in the next video. Thank you. Thanks a lot.